Thank you, Jessica. Is it sharing everything properly?
Yes.
Oh, thank you. Hi, good morning. My name is Vanessa Maike. I am a assistant professor in the computer science department. And I'm also one of this year's accessibility fellows. So as part of my work as a fellow, but also as a professor, I'm very interested in free ways or open source ways of creating accessible PDFs. So today's presentation is one step towards my study on how to create PDFs that are accessible using a tool called LaTeX. And unfortunately, I'm not going to show you solutions necessarily. I'm going to focus mostly on the currently open challenges because there's a lot of them. So here is the agenda of the presentation. First, I want to introduce to you what markup languages are, because that's important for understanding how LaTeX works. Then we're going to talk about generating accessible PDFs. Then markup of PDF content. Then I'm going to get into the accessibility challenges and then some concluding remarks. So reference material for this, for markup languages, I use Wikipedia. I have a good page about what they are, what it means. But the core content for this was taken from a post from Overleaf, which is the online tool for using LaTeX and creating documents with LaTeX. So they have a extensive post talking about the challenges of accessibility for tools like LaTeX or Overleaf. So let's start talking about markup languages. First of all, what is a markup language? You might be wondering. Markup language is a text encoding system which specifies the structure and formatting of a document and potentially the relationships among its parts. Markup language is also a set of rules governing what markup information may be included in a document and how it facilitates the use of the content in that document. And this goes either for humans or computer programs. So there are three main general categories of electronic markup. First is what's called presentational markup, which is used by traditional word processing systems, which produces what you see is what you get. So programs like Word, for example, or Google Docs or LibreOffice documents. In this case, you don't see the markup as a user. The markup is hidden from the human users. That's why it's what you see is what you get. You don't know exactly what's happening in the background. You just see, as you type in, you see what the document's going to look like. The other type of markup language is called procedural markup, which is embedded in text, which provides instructions for the programs to process the text. Examples of this, there's one called trough, text, or tech, which is what LaTeX is based on, and markdown. Markdown is what's used in GitHub. If you ever used GitHub to create your own repository, when you do a README file, it's on Markdown. But even more popular than that is Discord. If you ever try to type in formatted text into Discord, like bold, italics, or headings, or anything, that's Markdown. In procedural markup, text is often edited with the markup visible and directly manipulated by the author of the document. So in Markdown, for example, if you want something to look like it's bold, you're going to put two asterisks before and after the text that you want to be bold. So you are seeing the markup. The two asterisks are a type of markup. Finally, we have what's called descriptive markup, which is specifically used to label parts of the document for what they are, rather than how they should be processed. So the objective here is to decouple the structure of the document from any particular treatment or rendition of this document. Examples of this are LaTeX, the topic of this lecture, HTML, which was very famous for creating web pages, and XML, which is used for various types of metadata. Now, I've shown you these three categories, but I'd like to note that there is a considerable blurring of the lines between the types of markup. It's not necessarily binary, especially modern word processing systems. So maybe some processing systems blend a little bit of the two, and that's okay. So, important question, what is LaTeX? Obviously, it's a descriptive markup language, but it's also a document preparation system for high quality typesetting. So you can either pronounce it LaTeX or LaTeX. Two options for pronouncing that word. LaTeX is most often used for medium to large technical or scientific documents. So I find it very useful for writing papers for conferences, so you don't have to worry about the format of the document. If you need to resubmit that to a different venue, you don't need to worry about retyping everything or reformatting everything. You just change the libraries that you're using or the macros that you're using, and that will automatically change the formatting. That's why it's decoupling the structure from the content. And it's important to note that it's not a word processor. LaTeX encourages authors, again, not to concentrate, or rather to concentrate on content and not worry about the appearance of the document. So when you're writing, it looks really ugly. It's just a plain old text with the markups explicitly showing, which maybe for some users might be a bother. But the upside is that you don't need to worry about how they're going to look. You don't need to worry about, is this going to be on the right page? Is this going to have the proper subtitles, and etc. Usually that's taken care of for you. All right. So now that we understand a little bit what markup languages are and what LaTeX is, let's understand what entails generating accessible PDFs. Generating PDFs is very easy, but how do we make them accessible? So we have a few options of starting points to create an accessible PDF document. We actually have 4 possible starting points. We could have the source document, which is when you have your LaTeX or your HTML or even your Word file. However, there are 3 other options. You could have a poorly tagged PDF that you need to fix. You could have an untagged PDF that you're going to need to fix even more. Or you could have a paper or scan document and what's called OCR. I believe another fellow is going to talk more about that. So the 3 later options are challenging in their own ways. So supposedly having the source document is the optimal way for creating an accessible PDF because you have more control over what's on the back end, supposedly. So that's what we're going to focus on. Having the source document is the fastest and easiest way to create an accessible PDF because you can optimize the source file. For example, if you create a document in Word that follows basic accessibility considerations, as other colleagues have talked about how to do accessible Word or Google Docs documents, that is a form of optimizing the source file. In particular, considerations about semantic elements, headings, text, alternative text, color contrasts, links, tables, all those good practices that if you're not familiar with, I highly recommend other lectures where people are talking about those things. It's a good thing to know, regardless of what you're doing. So an optimized source file, meaning a file that follows these good practices for accessibility, allows you to create what is called a tagged PDF. And you may have heard this before, but what does it mean? What is a tagged PDF? A tagged PDF is the name given to a specific type of PDF file, which contains additional data and data structures that are not present within the untagged PDF files. So there are two key concepts underlying what we consider a tagged PDF. First is defining the logical structure of content in a PDF file. And next is the markup or tagging of PDF content with a set of standard content types. So we're going to dive a little deeper into these two things. What is a logical structure and what are content types? Starting with the logical structure. When you have long documents, content is usually partitioned into a sequence of smaller content items. For example, a book. Yes, a book, printed book or a digital book is typically broken into chapters. Chapters are divided into sections. Sections are divided into subsections, and they each contain paragraphs, tables, figures, lists, etc. So that's one way of partitioning content into smaller content items. This type of structure and organization of content for any document is referred to as its logical structure. So here's a formal definition of logical structure from the Encyclopedia of Database Systems. Logical structure refers to the way information in a document is organized. It defines the hierarchy of information and the relation between different parts of the document. Logical structure indicates how a document is built, as opposed to what a document contains. So the logical structure of a PDF file is essential to accessibility software. For example, if you have text-to-speech, any assistive technology that uses text-to-speech, you need to ensure that the content is being read out loud in the correct order or sequence. And that, as we will talk more about later, is affected by the logical structure of the PDF or of the tagged PDF. So one thing about tagged PDF is logical structures. The other thing is content types. So recording the logical structure of a PDF document requires a set of meaningful names assigned to the types of content that are found in a typical PDF. Identifying sections of content that, for example, represent headings, paragraphs, tables, lists, and so forth. In the same way that you do with Word, you sometimes don't always think about it. A lot of people don't know that you can actually mark up headings in a Word document. You don't think about the semantic value of that. Here, you kind of have to do that. The markup language forces you to do that. When you're creating a tagged PDF, you're forced to think about that. It's more explicit. But those things exist both in something like LaTeX or something like Word. Another requirement for content type is to clearly identify any PDF content that should be ignored by assistive software. For example, page numbers is something that is important for someone that's looking at a document or flipping through a document, but this information is superfluous to those with severe visual impairments. They're just here listening to the content aloud. So this is information that should be ignored. So coming back to tag PDFs, the mechanisms used by PDF to determine a document's logical structure are, by design, flexible. So in principle, different applications that generate PDF files could use names for content types using any convention of their choice. However, to provide consistent results across different PDF processing applications, Adobe, which is basically the one who dominates the PDF format, define a set of standard names of content types. So when you're creating a tag PDF, you could do like XML where you define what you're going to call each metadata. But we do have standard names for the different tags, and a lot of them are similar to what we have in HTML. So within the formal specification of PDF, those standard names for content types are referred to as tags, hence the name tagged PDF, or the notion of a tagged PDF. It means it's using those standard names of content types, or those tags. Now, I mentioned flexibility by design, and I want to make an analogy here with HTML in the sense that HTML also has a formal specification with the different tags that you can use to create web pages. So you have a large number of predefined tags. This large number allows flexibility in how you're going to combine these tags into an HTML document to create a web page or whatever it is you want to do with it. In a similar way, Adobe's tagged PDF specification provides a number of predefined tags with very few restrictions on how you're going to combine those tags to create a PDF. So you have the specifications for the tags, whether you're creating an HTML page or you're creating a tagged PDF document. How you're going to do that is up to you as an author. There's a lot of room for creativity and hence the flexibility. So this is by design a great deal of flexibility. And the reason I'm highlighting this now is because this is going to come back as one of the challenges we're going to look at. So know that this is a good thing, but it also brings challenges. Okay, so let's talk about markup of PDF content. And this is where it gets a bit technical, but bear with me. There's something that we call the building blocks for tagged PDFs. And if we look at the lowest level, the process of recording the meaning of a PDF page content begins with marked content sequences. Marked content sequences, or MCS, I forgot to put the acronym on this slide, are assigned a unique numeric identifier, just called the marked content identifier, or MCID. This is an integer that can run from 0 to some maximum n on each page. So each page has a quantity of marked content identifiers. These marked content sequences are the building blocks to assemble higher level data structures called structure elements. Structure elements contain a tag, which is the name of the type of content item that they are representing. So a paragraph, a heading, table, same. You can think, if you don't know how to build PDF, you can think about HTML or even more low-level word semantic tagging. So through a form of what's called parent-child data relationship, collections of structure elements are combined to create linked data structures. These linked data structures represent more complex data items like numbered and bulleted lists, tables, mathematics, and anything that you wish to do in LaTeX. Ultimately, the entire collection of structure elements contained in the PDF file are further linked together and combined to create the logical structure of the PDF document. So before I talked about logical structure and content types, high, like top level, now I'm going bottom up, right? Explaining what's most abstract concepts involved in creating a tagged PDF. So if this is not making sense, it's okay. I just thought it would be interesting to understand how tag PDF is built. And I'm not getting into the really technical part here. If you go to the link on Overleaf, the Overleaf post, they go into a little bit more detail. Now, tag PDF files contain an object that's called the struct tree root. The struct tree root points to structure elements that act as the starting point or the root of the document's logical structure tree. So thinking back to the concept of parent-child data elements, so the data elements are linked in this parent-child relationship. So if you think, again, with the analogy of a book, you have a chapter has sections have paragraphs. So that's a sort of parent-child relationship. Paragraph is a child to a section is a child to chapter is a child to the whole book. So usually the root of the structure tree starts with a single structure element that is called document, or the content type of its document. This document contains numerous child structure elements that collectively represent the entire content of the document. So software that produces accessible PDFs via tagging has to build this very complex data structure, including text engines and LaTeX. So just to understand the technical challenge here, that is to build a tagged PDF is not a simple thing. It's not something that's often talked about. So I thought it was interesting to bring this to the presentation. So here are two examples, or two screenshots of examples. Looking through Adobe Pro, it lets you look at the tags and the tag structure of a document. So here we have a tagged PDF, and this is the tree, or sort of the internal PDF structure, I guess is a better way of calling it. If the PDF is tagged, you have the struct tree root element, and then you have parent tree and all the associated data structures that go with it. If you have an untagged PDF, for example, something that you created from OCR, something that was like scanned documents, not OCR, but scanned documents, then it will likely be untagged. So it doesn't have the struct tree root element because it was not generated with tags. So that means that the content in the document doesn't have those semantic markups. So you don't know what content types are in that document. So just to summarize what I just talked about, here's some images also from the Overleaf post. We have a PDF containing multiple pages. These PDF pages contain various content items. So we have graphics, we have headings, you have paragraphs, you might have tables, etc. So each of these content types are stored as a content stream. It's called a content stream inside the PDF file, which is very similar to this concept here. This could be considered this is the content stream. So the content stream has different marked content sequences or MCSs to identify groups of operators that collectively are responsible for drawing fragments of the page content. So the software that processes this information knows what they need to draw to generate the actual PDF page, and in what order they need to draw it, or whatever other parameters are specified here. So this is very like low-level machine stuff, right? So these market content sequences are then combined to create higher-level objects, which are the structure elements. These are what we call the tags, or they use the tags to identify content items they represent. So the graphics, the headings, the paragraphs, etc. These structure elements contain one or more marked content sequences. So you see, it's not a one-to-one relationship. It's actually n-to-one relationship. So every structure element has a tag which identifies which type of content item it is representing. Now, these collections of structure elements are linked together in the parent-child relationship to represent complex content items like the things that we actually see, the lists, table of contents, tabular contents, etc. And then finally, all these structure elements are linked to form the tree structure that represents the PDF's logical structure. The root of that tree structure is stored within another PDF object, the struct tree root. The leaf nodes of this tree are the marked content sequences in the content stream. So the top level structure element is usually tagged document, forming the root of the logical structure tree. And then further structure elements are linked together in, again, the parent-child relationships to build representations of more complex content items, like the things we see in documents. So it sounds complicated. I think it is complicated, but it's interesting to understand how all this is done so that we know or have an idea of what is happening on the background when we're trying to generate PDF. This will help us to understand the challenges of creating accessible PDFs. So here are some of the accessibility challenges I would like to highlight. I'm sure there are more, but there's only so much time we have to talk about this. So the challenge number one is the ambiguity that comes from the flexibility that I mentioned a few slides ago. The content types or the tags for PDFs give you a lot of freedom or flexibility of how you want to structure your content, but that comes with a price. The inherent flexibility of the tag PDFs combined with how people are going to interpret accessibility standards or any other type of standards, even for creating PDFs, will naturally impact developers of document authoring applications. So if you're not involved in software engineering or software development, you might think that it's an exact science. It's like we imagine this and then we create it exactly how it's supposed to be. But no, software comes from requirements, which come from humans. So requirements are susceptible to ambiguity. So when we're creating a software that's going to create accessible PDFs or PDFs, it's unfortunately susceptible to these ambiguities. So it might interpret, the people who created that software might have interpreted accessibility standards in one way, and then people who build another software, they're standing in a different way. So you can have slight changes, even if there are slight changes or maybe grotesque changes across different software. So which combinations of tags should be used to represent user-created content when you're outputting it into a tag PDF file? It can change across authoring applications. Now factor in also the limitless ability of users to construct all sorts of content. Again, creativity brings in happiness and flexibility, but it also brings in a bit of chaos. So when you account for that, you can see that automated production of accessible tag PDFs is a big challenge. And as far as I understand, or as far as it's within the post I read, this is still an open challenge. Challenge number 2 is the reading order. So a tag PDF is the mechanism which enables the production of fully accessible PDFs, or at least that's what we are understanding. I hope you're understanding from all this talking I've been doing. However, we have to note that just because a PDF is tagged, it does not automatically mean that it is fully accessible. So all content items in the PDF should be tagged to create the logical structure, which ensures that content can be accessed and read in the correct sequence, which is what we call the reading order. Ideally, when we tag a PDF we created, it should have, or we imagine it would have, already embedded into it the proper reading order. However, that does not always happen. Suppose a page started with some text, followed by a table, and concludes with a graphic. So the natural reading order, especially for fully sighted people, would be you first read the text, then you read the table, and then you read the graphic. Or at least that's how you would expect a screen reader to look through this content, because that's the order is showing up on the rendered page. But when you write this to a PDF, again, thinking about all that backend that we talked about, the software generating a content stream for that page could actually change this order. So the software could start with operators to draw the table, then output operators to produce the graphic, followed by operators for the text. So in the content stream, this would produce a different content order. It would start with a table, then go to the graphic, and then go to the text. So everything, when you're looking at the document, will be placed at the correct position. When you're viewing the page, for fully sighted readers, it's following the original reading order. On the back end, however, this was generated with a different reading order. So the visual experience for the PDF readers is not affected. Fully sighted users are not affected by this problem. Because the order in which the items are stored inside the content stream of the PDF page is of no interest to the visual readers. They will experience a complete rendered page with everything in the correct location. However, assistive software that relies on the ordering of items in a content stream faces difficulties when the content order is different from the natural reading order. So again, going back to the idea that creating software is not a whole exact science, we have the problem of different people creating different authoring PDF tools. They're going to interpret differently how to generate the tag PDFs. So you already have the problem on the authoring end. And then you also have that same problem on the assistive software end. On people who create assistive technologies can interpret those requirements for reading tag PDFs or reading PDFs in different ways. So depending on which software someone likes to use to read their screen, they might have different experiences. So that's another challenge. Challenge number 3 is about testing and compliance. Now, on the overleaf posts, they actually go through an example to show how reading order, even if you create a document with Word, you can have an incorrect reading order using a screen reader later. There's a whole example that I don't want to go through the whole thing on the presentation, but you can actually test it and see it for yourself how this can happen. So it's likely that the reading order issue would only be detected if the resulting PDF underwent practical accessibility usage tests. In other words, someone actually opened that PDF using assistive software. But if you are producing PDFs all the time, like if you're a professor or lecturer, you're producing PDFs constantly for your students, it's already a lot of work to make sure that the document is following all the proper good practices, guidelines, and whatever. Not everyone has the time to actually open the document, sit through, listening to how it's being read by assistive software, especially not different options of assistive software. So this can be an issue that will go undetected until someone needs to access the PDF with a screen reader. So the thing is, potentially, a document that has this problem could pass compliance tests because it follows the guidelines. It was created following good practices. So if you use an assessment tool and run it through that document, it's probably going to pass the compliance test, but then it's going to fail in a real world usage with a real user employing their screen reader on that document. So ensuring that the correct reading order, ensuring that the reading order is correct could require skilled manual intervention. And skilled is important, as you saw, is not a simple task to create a tag PDF, and you have to understand the back end to make sure that things are in their proper places. So this could require skilled manual intervention using advanced PDF editing tools, and usually tools are behind a paywall like Adobe Acrobat Pro. So not everyone has access to that. Alternatively, you could force authors to refrain from using a particular form of content, like don't use tables or don't use graphics, if you know that this is a problem. But then you need to be aware that it's a problem, and then there's a whole debate about how people should create documents. So it's something that's really hard to control. Challenge number 4 is space to separate words. I didn't even know this was a thing. But when you're using a word processor like Word, the space character, yes, that space, that huge space bar that's on your keyboard, is used to mark the end of one word and the start of the next. It's something that you use constantly, you don't even think about it. Text engines, however, do not use space characters to separate words in the typeset text. Instead, they use a form of flexible spacing called glue. And I don't want to get into the technical details of this. Just know that this is a thing. And it has implications for assistive software that's trying to read aloud the text in PDFs produced by text engines. So, and then one of the implications is that assistive software has to parse the content stream of a PDF page to extract the text that it needs to process. So that's another very technical challenge, really. So just to clarify, rather than outputting a space character, the separation of words in a text engine is achieved by moving to a different position on the page and starting the text for the next word. So the amount of space between words and paragraphs of text typeset, excuse me, made by tech engines varies from line to line due to how the line breaking algorithm works, which is, again, something I never thought about. So some concluding remarks. First one is that freedom has a price, as we talked about a few times. As an authoring tool, LaTeX provides authors with near unlimited flexibility in the range and complexity of documents that they are allowed to create. LaTeX also supports extensibility via thousands of add-in packages that authors can use as part of their documents. And finally, you have the freedom as an author to write your own macros if you're into that kind of thing, or even redefine existing ones to achieve specific effects. So a lot of freedom, but all this freedom needs to be orchestrated if LaTeX is to automatically generate correctly tagged and accessible PDF output. So freedom is great for creativity, but again, brings chaos. And to make sure that things are following known good practices and, like we talked about before, unknown good practices, then there needs to be a little bit of control. But I also wanted to highlight the power of community, which is why I think LaTeX is very interesting. Unlike Word, which is hidden behind a paywall, or Google Docs, which is free, but you don't really have any idea what's happening in the background. You have no control over it. LaTeX is free and open source. So the wider tech and LaTeX community is trying really hard to address the accessibility challenges. The ones I talked about and others I haven't talked about. They have a tech user group, or TUG, coordinating research and development efforts for PDF accessibility and PDF standards. And the tech or LaTeX ecosystem, like I said, there are thousands of add-ins and macros and all that, can be very intimidating and overwhelming, especially as you start to see all these acronyms. But there's a great potential for, again, open source and free ways of generating accessible PDFs, which is why I think it's interesting to dive in a little more into LaTeX, despite all the challenges. Thank you.
Thank you.